So the first thing we will start with is, we will take a line, and with respect to a line, we will learn how to draw a perpendicular bisector for any of the line of whatever measurement they will give. I will be taking few random measurements, but in a question, we can take any measurements as per what they give. So let's say there's a line AB. Okay, if I just want to show you the length of the line, so the length of the line is approximately, it's 7.5. Okay, this length is not required, it's just I'm showing you. And we are going to find perpendicular bisector of this line. So for that, what we will do, we'll take a compass. We'll take a radius on the compass which should be more than half of the length of this line. Look, somewhere over here approximately it will be half. Always take a radius which is more than half of it. And then we will cut an arc, keeping that compass on A. We will cut an arc above the line, and then same arc I will cut below the line also. You have to make sure that these arcs should be as small as it can be. Okay, after drawing these arcs, you will move the compass and you will place it on B. Okay, radius, you can see that I'm not changing. Whatever radius I have taken, it was okay, but now we have to use the same radius, and then we will repeat the process from the other side, intersecting the previous arc. Now this is not intersecting, so I'll just do it again. Okay, but it should intersect the previous arc at this point. Okay, similarly, if I go down, then it will go somewhat like this. Okay, so just have a look at these arcs. Okay, how the arcs were created. I repeat the process. You have to keep your compass at one of the point. You take a radius more than half of the length of the line that you have to take approximately, and then you have to cut an arc above and below from A. Repeat the same process from B, cut an arc above and below, and it should intersect the earlier ones. So it has intersected, and now finally we'll just join them. So if we join it using a ruler, okay, I will get this, and this is the perpendicular bisector for the given line. Okay, this will come almost equal to 90 degree. There is some scope of error which will always be there. So instead of 90 degree, if you are getting, let's say 89 degree, 91 degree, it is okay. But it should look proper, a perpendicular line. So this is how we create perpendicular bisector. The line is also perpendicular, plus let's say if this point is P, so then AP will be equal to PB. I can even show you on ruler also. In ruler, we saw that earlier the length of this line is 7.5. Okay. In fact, if I look at this carefully, the length of the line perfectly, it is coming at 7.4. Okay. So it will be, the midpoint will be somewhere around 3.7. So it is clearly visible that this is 3.7. So 3.7 each will be the length, and these labeling is not required. I'm just showing you as a proof. Okay, so this is how we have to draw perpendicular bisector. I will just apply area of a triangle, the conventional formula what we have done earlier, that is half base into height. Base is A, height is B sine C, and that is how area of triangle is proved as half AB sine C.